Okay, this meeting of CPOC is called to order. Are there any comments from the public to be made? None? Then, next on the agenda is approval of minutes of the March 11th, 2013 meeting. Do I hear a motion? Second. All in favor? Minutes are approved. Nuria Fernandez, are there any changes to the committee work plan?
Yes, Mr. Chairman. The committee work plan had indicated that the capital plan amendment will be brought to this meeting, and we are going to defer the capital plan amendment until the June meeting.
Okay. And no further changes?
No further changes.
Thank you. Next on the agenda is Bridges and Tunnels for the semi-annual capital program update. Joe Keane.
Thank you, Mr. Chairman. Good afternoon. For the semi-annual update by Bridges and Tunnels for CPOC, we're going to update CPOC on two projects and programs that we've previously briefed the group on in the past. One is at the Bronx-Whitestone Bridge, and the other at Verrazano Narrows Bridge. While we're waiting for this to load up, we'll also start off the briefing with an overall status update on where we stand with Bridges and Tunnels for the 10-14 capital plan.
It's in the book.
Okay, so I'll just first an overview on where we stand with the program. As noted in the second bullet on slide 2, if you can refer to the book while we're getting the technology working here. The capital program is for Bridges and Tunnels. It's our largest program, currently $2.079 billion. We have off that 78%, by far the majority, is basically the kind of projects that you'll see illustrated in this update: roadway, deck, and structural projects in the main. These are by far the largest chunk of the capital program. The capital program initially, when it was first approved, was almost $2.5 billion. With the targeted savings, we've been able to take that down to the current value of $2.079 million, and that's been achieved largely. We've been reaping the benefits of a favorable market and largely through good bid savings and some other efficiencies. We've been more or less able to preserve the same complement of projects that we started off with. At the bottom there, you see one of the strategies that you'll see featured in the projects that I'm going to talk about that we've been using quite a lot is inter-agency agreements, memos of understanding, MOUs, with our regional partners such as New York State Department of Transportation and Department of Parks and Recreation. And next slide. Status as of today, we've committed about $1 billion, or 48% of the program. Over the last 3 years, we've committed 274 tasks, and that compares to a baseline of 255 for the same period. It's a little difficult to see, but the top two projects that are highlighted on that table, VN 80 and BW 89, those are the two projects that we're going to feature in our presentation today, and they happen to be the largest commitments we've made to date. Next slide, please. For this year, 2013, this is the plan. We have 102 commitments, $323 million in total commitments. And the project that's highlighted at the top of the slide there, VN80C, entitled Bus and HOV Ramp Improvement Construction at $80 million. That is the major project this year, and it is also a project we're going to talk about later in the presentation. Next slide. So jumping into the Verrazano Narrows, this is an aerial view to sort of the bottom left. As you look at it is the toll plaza area in the blue-green color. Currently, there's a toll plaza interchange project going on there. It's about 50% complete. Project's been implemented with close cooperation and under a MOU framework with New York State Department of Transportation to implement complementary improvements on the Staten Island Expressway. The main span project on the top there that says 2012 to 17, replacement of upper level deck. That is the major project we're going to be talking about today. That's VN80B. And that project was awarded a few months ago. We're in the early stages of mobilizing and ramping up to get going with that project. And the third project that's shown there, which there really should be something that points to the Brooklyn side on the top right, that is the bus HOV ramp improvement project, which we'll also discuss. Jumping into VN80B, it's a replacement of the 1960s concrete filled grid deck with the new steel deck. This project enables bridges and tunnels to achieve a number of important goals. The main one, I think, for regional importance is we were able to, by reconfiguring the upper level geometry, we were able to add a seventh lane on the upper level, and as you will see, that allows us to create a reversible bus HOV lane on the upper level of the bridge. We're replacing the drainage system. We're upgrading seismic wind performance and load rating off the structure, which will help with its long-term resiliency and performance, and new sign structures and new energy-efficient LED roadway lighting on both levels will also be implemented as part of this project. I mentioned the project was recently awarded. You can see the budget information on the bottom. Overall budget, $305 million. This cross-sectional view on the top, you see that there are 6 lanes on the lower level, eastbound, westbound. That's nothing changed. But on the upper level, you'll see there's a new lane, so to speak, that's created in the center by taking out the median that currently exists on that upper level, and by use of a movable barrier, we're able to create a 7th lane. And in the AM peak period, when traffic is heading from Staten Island to Brooklyn predominantly, that lane will be operated to favor the predominant traffic direction towards Brooklyn, and conversely in the afternoon, evening rush hour, it will favor the Staten Island bound outbound traffic. The VN80C project I mentioned, that's the bus HOV ramp improvement. This project basically connects that 7th lane that you just saw, and connects it from the upper level and takes it all the way down to the Gowanus Expressway, where it joins up with improvements that are currently underway being implemented by New York State Department of Transportation. And again, the tie-ins and the work necessary for the two projects to dovetail have been worked out in detail between the two agencies and are part of a regional agreement and MOU for these improvements. The project involves creation of a new ramp, which you'll see illustrated in the next slide, and it is currently out for bid. We anticipate getting it awarded mid this year, if not by the latest 3rd quarter this year, complete in 2016. We anticipate, because it's mainly speaking, new construction of a new ramp. It doesn't interfere with the right-of-way until you make the final tie-ins to connect to the mainline structure, that there will be minimal impacts on our customers as we're implementing the project. This slide illustrates the ramp. Basically, what you're looking at here are the approach ramps to the Verrazano on the Brooklyn side of the bridge. There's quite a lot of ramps going to and from both the lower and the upper level off the bridge to the Bell Parkway and to the Gowanus Expressway. And highlighted in green is the new bus HOV ramp, which the top of the slide is the main span, sort of the Staten Island side, and the bottom of the slide is heading towards the Gowanus Expressway in Brooklyn. So you're basically coming off the center of the upper level of the bridge that we just saw earlier, and with this new ramp, you're threading your way through the existing ramps and coming down and touching down onto the Gowanus Expressway. The two ramps that are shown in the brown color are new replacements of pieces of the existing Bell Parkway ramps. This was an innovative solution that we came up with to improve the grade of the new ramp by switching the upper and the lower level ramp connections and rebuilding those ramps now rather than later. We were able to greatly improve the geometry of this improvement, and is an example sort of what we would characterize as a best value strategy in implementing the capital program. Next slide. Moving to the Bronx-Whitestone, as the committee knows, we've been working on the Bronx-Whitestone Bridge for quite a while. We've undertaken major work back in the early 2000s with the improvements on the main span, taking the weight off the suspended span by removing the truss, installing aerodynamic wind fairing to improve wind stability. That was in 2004. That was followed right after that by a suspended span deck replacement in 2007. We just concluded a complete replacement of the Bronx approach to the Bronx-Whitestone Bridge. That was completed in late 2012. And we're now sort of in the final phase of the current major program of reconstruction at the bridge, and that is the replacement of the Queens approach, which is to be completed in 2015. The project really has three distinct phases. We've completed the first phase being construction of new piers and foundations. Basically, that's been done completely without impact to traffic under the existing structure. There's a phase two when we start actually working on the roadway. That's about to kick off in early June, when we'll be reducing the bridge to a 5-lane configuration with a 3-2 configuration favoring predominant traffic direction, and a final phase 3 where we demolish the old substructure and finish out the project. This is an aerial view of the Bronx approach replacement, but it's illustrative of the kind of work that we'll be doing in Queens as well. If you from the bottom of the picture shows the Bronx anchorage area of the main span, and then you see that the roadway sort of flares out, and basically what's happening there is we're widening out the structure to create a 3 standard 12-foot lanes and a shoulder to meet modern standards. So we're having to build out from the existing choke point at the suspended span and create a wider structure. The sort of cartoon on the top left illustrates the new 3-pier configuration with 3 12-foot lanes in each direction and a shoulder. The 3-pier system represents a big improvement in the redundancy and the resiliency of the structure. It used to be a non-redundant 2-pier structure. The project that we're talking about today, the Queens approach replacement, these are the project limits. Basically, to the right, you have the ramps coming off the Cross Island Parkway, and the Whitestone Expressway. These are on-grade ramps that are also being rehabilitated as part of this project. And then you have about a 1,000-foot long viaduct structure that's been completely replaced. And the project limits are more or less at the Queens anchorage on the left side of the slide. And this shows the budget situation. Current total budget's $166 million. Project's about 45% complete. We're still on target to meet the substantial completion date of early 2015. Again, this sort of illustrates the three phases of the project. Phase 1 is already complete. The new piers have been installed, and now we're starting the roadway replacement, roadway deck replacement, and that will run into late 2014, and then we'll finish up by 2015 with the final phase of the project. And again, we'll have 3 standard 12-foot lanes and shoulders on the Queens side as well. Just some photos depicting some of the construction. The top left, you have the augering in of the mini piles. The mini piles are you have 9-inch and 12-inch diameter piles that go down anywhere from some as deep as 85 feet. They're installed in clusters and provide the substructure support for the new pier system. The top right is the new retaining wall being installed. And on the bottom left, you can see some of the steel erection work going on. You can see in that picture the existing pier sort of on the inside of the new steel. That shows what we were talking about, that the existing structure is being maintained in place while traffic runs on it, while the new structure is coming out of the ground literally underneath the structure, and eventually we transfer the loads over and put the new structure in place, and then we can rip out the old substructure. And to the bottom right is some of the formwork for the concrete for the new piers being set in place, where again you can see the new substructure being built under the old existing structure. Okay, so just recap where we are with the project. As of this month, we're 45% complete. This project was previously presented at CPOC as part of a risk assessment presentation. The risk assessment helped bolster our confidence in the risk assessment process, rather bolster our confidence in the current budget and our ability to finish the project within the current budget. And happy to say that with 45% complete, we're doing very well with that. We continue to monitor the risks on the project and try to stay proactive. The two things we're highlighting at the bottom that I think have been key to the success of the project so far: very active interagency coordination effort. One of the features of this project is we had to relocate a children's playground that was immediately under the structure in Queens. We worked very hard with the city agencies, principally Parks Department, and also the local community to find an alternate location that was suitable, and that has proven to be very beneficial in terms of allowing construction to move ahead unencumbered by having to work around the playgrounds, and has also garnered a lot of support from the local community because we were able to do that as part of the project. And then on the bottom, I think the project it definitely is a challenging project because we're working at close quarters with the community. There's a lot of impacts to both the Whitestone and Melba areas, and we've had a very proactive outreach effort with local civic and community groups and elected officials, and I think that has been very beneficial in helping the project move along. And that concludes my presentation. Thank you.
Thank you. Next is...
Mr. Chairman, can I ask a question?
Sure.
If you don't mind. On the HOV lane crossing the Verrazano, is there an intent to have Jersey barriers or some physical impairment between the HOV bus lane and the other traffic lanes? Or is it intended solely to be paint?
Okay.
Because I know the difference.
Yeah. Right now, the intent is for the lane to operate. It would operate pretty much the way, for example, the Tappan Zee Bridge operates, where you move the lane to favor the predominant direction, but there's no physical barrier that would prevent somebody, let's say, that wants to cheat and.
Joe, but I believe you're when the barrier will separate opposing moves
Yes.
of traffic, right?
Opposing traffic
you
only.
won't have a barrier. You won't be able to preclude someone from entering the lane that shouldn't, but all that traffic's moving in the same direction.
My question is, and that's right. Those are two different issues. And I agree. The problem is going. Well, the question is, if we're not planning, the collective we are not planning on having a physical barrier between the 3 lanes going in one direction and the HOV lane going in the same direction. I understand most people go the other way, which is understandable. That what are we doing then? We must assume then that there are going to be people in the lane who don't belong in the lane. Always happens.
Yeah.
Take the Long Island Expressway, for example, okay, because all we have is paint. So my question is, are we going to be responsible for that enforcement? Or is somebody else going to be responsible for that enforcement?
I nominate Alan Capelli.
Well,
Mitch, as we routinely do, we enforce the traffic regulations on our facilities.
Right.
Our speed enforcement units will monitor the usage of the lane. Naturally, pulling vehicles over that don't belong in an HOV lane is extremely dangerous.
I fully understand.
We will make every effort to find that location to pull cars that are illegally using the HOV lane over. Now, does that mean 100% compliance? As we all know, that never means 100% compliance. But we make every effort to enforce the traffic regulations, and the counterflow will be protected by a barrier.
Right, counterflow I understand. The problem is going to be, and I can only tell you by experience, in the issue is going to be twofold. You're absolutely correct. It's going to be almost impossible to pull over a car which is in the HOV lane because, number one, there's no place to do it where the HOV lane is because you have no space there, unlike the difference between the HOV lane, which is now in Suffolk County, and the one in Nassau County. And secondly, you're never going to move a car across 3 lanes going the other 3 lanes to stop them, which means that what they ended up having to do in Nassau County, because they had a number of accidents with police officers attempting to stop people, is that they now have had to go back and actually build areas in which there are places for the police to stop. So the concern obviously is not once you can't, I mean, there's also the question of how you get in the ramp, okay? Unless you have a police officer sitting there, which is what they had to go to, I'm concerned that we're going to end up having an enforcement issue both on the bridge itself and off the bridges. Not that I don't support bus HOV lanes. I strongly support them in that regard. I'm concerned that we're going to have an enforcement issue both on the bridge and getting off the bridge because of that. That's my concern. Not that I don't support the HOV lane. I've always been a great supporter of it, but having the experience of what happens, I know what's going to happen.
No, I don't disregard your comments.
That's what's going to happen.
The-
You're going to cross the lane and go in and assume they're not going to get caught.
Right.
Why can't you have cameras like the red lights in the city?
Let me, Norman has a question, and then Alan, I think.
Well, I mean, it's what Carl was interrupting me to say. Is my point is, have you studied remote monitoring? I mean, as much as I like to employ police officers and other people, those sort of monitoring through the rest of the world's done by cameras, and is the only efficient way to do it. I mean, if you want to keep the traffic flowing, you really can't pull the car over. It's, same issue in the city. but they restricted speeding cameras in the city is the issue rather. But it's fairly simple to monitor the thing with. I mean, have you studied it, and why have you rejected it, and if so, why?
Let me see if I can answer that. We realize that it's that operating a bus HOV lane that is also contiguous with a bus HOV lane that's operated by another entity is a complicated matter. So because of that, we are entering into a study jointly with New York State Department of Transportation, and we may involve other agencies to really study more the operation of this contiguous HOV lane and how best to operate it, because there are a number of challenges, such as should there be a single entity that moves the barrier? Where is the terminus for where the barrier machine is going to be stationed? There's a whole host of operational issues, including the ones that you mentioned about monitoring and so forth. And I anticipate those issues will be further studied in this operational study that is just underway right now. And I think once we have moved further along with that study, we will be able to provide some more precise answers to the very valid questions that you're raising here.
Alan Capelli.
Yeah, the fact of the matter is that on the bridge itself, it's not going to be very easy to be able to pull people over. But on both sides of the bridges, there are areas where people currently get pulled over if we don't have the lane on the bridge, but you have the HOV up until both points, and they get pulled over on both sides of the bridge. So if the infraction occurs on the bridge, our officers, it would seem to me, can just follow them into the area beyond the toll and pull them over, and the same way the New York City Police Department is currently doing.
Okay.
It's not as simple. I agree. It's just not as simple as that. See. About it, you need to talk to the people who had it, because they'll give you a lot of experience as to what does work and unfortunately what does not work.
If I may, I think Jim Ferrara has gotten a lot of feedback here and will get back to us, I presume, at the next meeting with some more insight. Is that correct?
That is not a problem. We will.
Okay, are we ready?
Yes. On the Bronx.
I guess we're not.
On the Bronx Whitestone project, in the briefing I heard that there'll be lane widening. Is that the only reason to do this project? What was I wasn't here last year, so.
Okay. Well, basically, this is a 1930s structure that was in a very bad state of repair. It needed to be replaced, basically from a state of good repair point of view. So in doing the replacement, we took the opportunity to bring the replacement structure up to current standards, so it meets all current standards for geometry, for seismic performance, for load rating, and so forth. So, no, it wasn't done simply to widen the structure, but in replacing the structure, we want to, where possible, meet current standards.
In other words, it needed to be replaced because it was worn out, because it was rusted away. I mean,
Yes. Yes.
If it's obsolete, that's one thing.
We were actually having to spend quite a lot of money in our operating budget just making temporary repairs. So it really was the economics of doing this capital project, so to speak, were very sound.
Okay, I mean, I'll talk later about why structures should not, steel structures, from what I understand, should not deteriorate that quickly. So I'm kind of, that's why I'm wondering about this.
All right. I can personally attest to the fact that it was in very poor repair,
Isn't there a seismic issue too?
Yes.
having come over it a few times.
There's a seismic issue too, and the design standards in the 1930s are different than the seismic standards are today.
Okay. Thank you.
Thank you.
The next is a risk assessment update. There will be no presentation on this, but you see it in your book. Are there any comments or questions on it? If there are none, next is from New York City Transit, MTA bus time update. And in consideration of the fact, I hate to do this to you, that we're running way behind schedule, I would ask everyone to use an economy of words. Yes.
Okay, good afternoon. My name is Craig Cipriano, Vice President Business Strategies, Bus Operations, and this is Sunil Nair, Bus's Chief Technology Officer. Today we're here to give you an update on the progress of MTA bus time. Just to recap the functionality, MTA bus time provides our customers with accurate, real-time bus location information. Customers have access to MTA bus time information using various digital and mobile interfaces. If they're at the desktops, they can use the web browser that shows a real-time moving map of buses along a route or multiple routes, the picture that you see on the right hand of the screen. They can also use their smartphone or request the MTA bus time information via text messaging. Lastly, if they're waiting at a bus stop, they can always point their smartphone at the QR code printed on the paper schedule insert at the bus stop to find the next several upcoming buses. With respect to deployment, we have MTA bus time deployed to over 2,000 buses, or roughly about 36% of our 5,700 bus fleet. We have MTA bus time deployed to every bus and every route in the boroughs of Staten Island and the Bronx. In addition, we have MTA bus time deployed to the routes of the B63, B61, and SBS 34. At the last board meeting, as mentioned by Acting Chairman Ferrer, we are committed to completing the full deployment to all boroughs by April 2014. On this slide, I wanted to highlight and share some metrics collected from a survey performed by the MTA with our bus customers. The results show that 79% of our customers are satisfied with the MTA bus time product, while 82% said that MTA bus time is useful in estimating their wait time. Most significant among the numbers is the fact that we saw a statistically greater satisfaction with overall bus service among those obtaining MTA bus time information versus satisfaction among all respondents. This shows that customers' perception towards overall bus service is higher when they have an effective means of predicting where their next bus might be prior to waiting at the bus stop. With respect to usage, 94% of customers told us in a 2011 survey that they would want to see bus time available on all routes in the city. If numbers from the existing two boroughs are any indicator, text message usage for year-to-date is about 2.3 million texts, averaging about 36,000 per day, while mobile website usage year-to-date is about 5.2 million users, averaging about 77,000 per day. Lastly, the website usage year-to-date is about 589,000 with an average of 7,000 events per day. Customer feedback has been generally very positive, with feedback ranging from great idea, especially for mobile devices, to bus time has been a real lifesaver. We occasionally get feedback like, my bus didn't appear on bus time, which we have addressed and rectified as soon as we receive them. The main task, surely.
If that happens, does that mean the transponder in that particular bus is not working?
It could be a number of issues. It could be cellular connectivity, GPS, it could be hardware failure. There are a number of different issues, but we try to stay on top of that as best we can. The main tasks and timelines for system deployment are as follows. The contract for the remaining boroughs has been awarded to Cubic Transportation in February 2013. We are working to make sure that we have MTA bus time deployed to Manhattan in 2013 and the boroughs of Brooklyn and Queens by April of 2014. The installations are scheduled to begin in the second quarter of 2013. All of the necessary software development to support the wider deployment is proceeding on schedule. Again, the customer outreach informing customers about the MTA bus time deployment will remain similar to the efforts that we have performed in Staten Island and the Bronx. The efforts include exterior and interior bus ads announcing MTA bus time, an advance notice poster deployed prior to launch, a how-to brochure that will be published explaining the program and educating customers how to use the system, and of course, new guide-a-ride bus schedule inserts will be deployed to all the stops. In addition to the above, the MTA website and homepage will be updated with the relevant information. Total cost to implement MTA bus time is $60 million and is within our budget projections. The cost includes on-bus hardware costs covering installation, warranty, and maintenance for a period of 3 years, all software contract costs that will support MTA bus time expansion to all buses in all boroughs. The cost also includes software costs covering development, hosting, and maintenance, and include our initial implementation costs for text messaging and wireless carrier costs at $25 per bus, derived from the state contract pricing. Please note that text messaging and wireless carrier costs will become operating costs after the deployment is completed. Moving forward, we aim to ensure successful citywide implementation on all 5,700 buses by April 2014. We will also make sure that the MTA bus time platform is designed to be open, thus supporting other bus technology enhancements in the future. A case in point is the recently deployed traffic signal priority project that we worked on with City DOT and is on the SBS 15 route. In addition, we are also making sure that MTA bus time information is also available to other relevant customer information channels like the on-the-go kiosks. We are also working on fully incorporating the real-time location information from MTA bus time into our daily operational and service management decision-making. Thank you.
Thank you. Next is an update from Systems and Security Division. Mark Beanstalk, are you ready? And I likewise encourage you to employ an economy of words.
You don't have to encourage me all that much. Good afternoon. My name is Mark Beanstalk, and I'm the Program Officer for Systems and Security. Today I'll be updating you on two major projects, the Integrated Service Information and Management Project, as well as the VHF Radio System Project. Last year I told you of the efforts underway to provide train arrival information to subways, service management personnel, and our customers. Our long-term goal has always been to develop a system similar to the A Division Automatic Train Supervision System, ATS, and deploy it on the B Division. This system would provide centralized service monitoring at the Rail Control Center, as well as control of the B Division subway interlockings. However, a significant investment in time and money is required to modernize the B Division signaling system in order to control the interlockings. If you recall, last July I presented several slides highlighting the differences between the A and B divisions, the main differences being the size and track complexity of the B division, as well as the large number of interlockings which need to be modernized to provide automated control. Recognizing the need to begin providing information as quickly as possible, we have established an interim goal focused on train identification, train tracking, and service information. Achieving this goal is the focus of the ISIM project. There are four main objectives for the project. The first is improving train service management by enabling personnel at the Rail Control Center to know in real time the locations of all subway trains. The second objective is an improvement in safety and security through the sharing of real-time train status information and decisions. The third objective focuses on delivering train status information to our customers on the web, using apps on mobile devices, and on signs in passenger stations. And the fourth objective is to improve subways planning and scheduling through the analysis of historical train service data. To help ensure that we'll be proceeding on the best path, we are following a disciplined systems engineering process for this effort. We have already completed the concept of operations, taking into account all stakeholder needs and priorities. This living document will inform the master plan and become the cornerstone of the design efforts. We are currently completing the alternatives analysis component of the project master plan. The alternatives analysis will serve to build consensus among the project stakeholders regarding the best way to build and deploy the ISIM system. We have already decided how to partition the work streams within the ISIM project, for example, embarking on parallel paths to capture train location in the field, deploy the PACIS station infrastructure, and develop the system software for the Rail Control Center. We have decided that New York City Transit will take on a share of the system integration efforts together with the selected vendor. We are finalizing a decision regarding how best to procure the ISIM system and how to deploy the system in a phased approach. Moving forward, we will be developing a modular master plan reflecting the various ISIM work streams. This approach allows us to proceed with the work in a phased manner and start the work with the longest timelines earlier. This is a summary bar chart for the ISIM program. The schedule and budget will be formally established as we proceed through the master planning process and finalize the decisions which I mentioned earlier. This information will be provided to you at a future CPOC meeting. Yes.
Further, so in a 0 to 100 progress chart of what it takes to bring this kind of information to the B division, what number would you say we are at now, if it's doable?
It's difficult because of the way we partition the project into multiple work streams. So, for example, we've begun the process of designing how to bring the signal indications from the field back to the rail control center. That's very early. We're very early in that planning process. But in terms of how to proceed, we're fairly far along in the planning process. I'll add a note to provide a sort of a percentage update at the next meeting.
Go back to the last slide. This may be a better way to qualitatively state what it is. When we started this effort with a couple administrations back, there was an urgent need to try to get to the same level of functionality for the A division here. What you'll see here is a total completion way out in 2019, but you'll start to see some things at some stations in 3 to 5 year time frame. That's the idea. This is a tremendously large project, very complicated integration project.
You actually see you hear some things now because there's a voice telling you, you know, the next Uptown Express train is
Right.
arriving on the express track or local track, whatever. It just can't tell you which one yet.
In certain locations, we don't know which train. We know there is a train. In other locations, we have a little more granularity. For example, on the Flushing line, where there's only one service, but we do actually tell you a time of arrival, a countdown on the Flushing line there.
Where parallel trains originate at different starting points, wouldn't that be a way for the system to know which train was approaching?
Yes, but yes.
Yeah.
Okay. The second project which I will be presenting is the VHF radio system upgrade. The project was awarded to Alcatel-Lucent USA in February 2012 and is progressing with no major issues. The project will replace and upgrade the subway's VHF radio system used for train radio communications, as well as NYPD Transit Bureau radio communications. The current system is over 25 years old, extremely difficult to maintain, and does not meet current FCC Commission standards. The project is proceeding on schedule and on budget. We have already completed several major activities, such as the system conceptual design review and system simulation testing. All of the equipment for the VHF radio contract has been approved, and the contractor is working at all 4 initial build sites. During the next 6 months, we will complete both the preliminary and critical design reviews, conduct the various system and equipment tests, and complete the equipment installation at the 4 initial build sites. Work on the critical milestones is progressing on schedule, and there are no major issues to report. Thank you.
Yes, the independent engineer agrees with the cost and schedule of this project and the characterization by the train agency. Thanks.
Signals and train control division.
Yes, sir. Good afternoon. I'm Nitish Patel, Program Officer for Signals and Train Control. Today I will brief you on the status of several of my CBTC and signal projects. The Flushing CBTC project is the second CBTC project at the New York City Transit. This project will modernize 2 interlocking, First Avenue and Times Square. All other interlocking will be made CBTC ready, and CBTC will be overlaid on the entire Flushing line, including the 34th Street extension. This contract will also equip 46 trains with the CBTC equipment. This contract activity do not cause any delay to the opening of the 7-line extension. The CBTC project on the Flushing line continues to remain both on schedule and within budget. Since my last update to you, the final design review was completed. Rooms at 61st Street and Junction Boulevard has been erected, and the equipment for Times Square interlocking has been delivered. Over the next several months, factory accepted testing for the CBTC and SSI equipment will commence, and the new interlocking at the Times Square will be placed in service. Risk assessment workshop was conducted on March 11th and 12th by MTA consultant. A draft report was received, and NYCT is currently reviewing the project and the report. Two major areas of concern are track outage availability and the availability of all CBTC equipped train to start the final cutover. I will talk about these two during the next two slides. NYCT is working on a mitigation plan and will share it with the risk assessment consultant in the next few weeks so that they can finalize their final report. And I will share with you the final report and their finding in the next meeting. As I reported last time, radio development is critical, but it's currently the way we developed the radio, we divided the radio communication system into two components, hardware and software. The hardware manufacturing is ongoing and software development is on schedule. The second critical milestone is the factory acceptance testing for CBTC system software, which is also scheduled for third quarter of this year. Sure.
Will we get we won't get effective use of CBTC on the flushing line until the R188s are delivered or with existing equipment?
No, the CBTC will start in 2015 from Main Street onwards.
With existing R62As?
No, not R188.
That's what I'm saying.
Right.
So we have to get those in before we'll get effective use of CBTC.
Exactly. And I think the last car delivery is scheduled for February 2016. So once we get all the train, we're going to remove all the equipment.
Yeah.
These are the other three critical milestones we monitor all the time. The first one is the installation of the CBTC equipment on the first train, which is planned for the first quarter of 2014. Currently, there are no issues with the interfaces, and hence the delivery of the first train of the CBTC testing. The second critical activity is the geo availability. NYCT continues to coordinate the signal work and track work. Successful coordination between the track and CBTC contractor allowed for over 30 panels to be replaced in 2013. And we're going to continue to work closely with all the parties to maximize the geo piggybacking opportunity. Getting the last train in February 2016 is critical for this project because once we have all the train, 46 train, the final cutover and the removal of the existing signal can start. There is a potential for delays for the acceleration and braking test due to the damaged test track in the Rockaways because of the superstorm Sandy. At this time, Dyer Avery line is utilized for testing to minimize the impact on the Kawasaki car contract schedule. The next project is the CBTC Culver Line Integrated Test Facility Project. NYCT awarded this contract to Siemens Thales Consortium in September 2011. In the next few capital program, NYCT will be focusing on modernizing the B division, primarily the I&D, using the CBTC technology. Due to the diverging route and not having dedicated car fleet for each line, future CBTC equipment must be proven to be interoperable and safety certifiable for safe passenger operation. This project will update and finalize CBTC interface and interoperability standards, develop two safety certifiable CBTC systems. Also under the same project, the contractor will provide an integrated test facility at 2 Broadway and a test track on the Culver line, which can also be used to qualify additional CBTC suppliers. This project is within the schedule and budget at this time. The project is progressing well. Final design review is almost complete and hardware procurement is ongoing. Factory acceptance testing is planned for the third quarter of 2013 and interoperability testing is planned for the end of this year. Both the critical milestone, availability of the test facility and the factory acceptance testing, are on schedule. There are several conventional signal projects which I will briefly update you on. The first is the Church Avenue interlocking. This project was awarded to LK Comstock in June 2010 and is for the modernizing the interlocking at the Church Avenue on the Culver line. This project is on schedule and within budget. This project is successfully coordinated with the 4th Avenue Viaduct project. In November 2012, we awarded 2 signal interlocking, Union Turnpike and 71st Avenue, on the Queens line to the 5 Star Electric.
You're going to want to change that slide because you have 71st Street in 2 places instead of 71st Avenue.
That's correct, right? The next slide. In January 2013, we awarded Roosevelt Avenue interlocking contract on the Queens line to 5 Star Electric. These 3 interlocking bids were competitive thanks to the addition of the 3rd signal supplier, increasing the competition spectrum. The last month, we opened the Dyer Avenue line signal modernization contract. This project will install 2 different solid-state interlocking systems, the first at the Dyer Avenue and the other at the Morris Park. The low bidder is JTJ Contracting. The qualification hearing is ongoing, and the project is scheduled to award by end of this month. Currently in design phase, we are doing the design for the 34th Street and West 4th Street interlocking project. Both projects are planned for award 4th quarter 2013 and the 1st quarter 2014 respectively. So by 2014 1st quarter, Signals and Train Control will have awarded $1 billion in signal modernization projects. That's conclude my presentation.
Thank you. IEC?
Yes, thank you. On the CBTC project, the independent engineer finds that while there's no schedule contingency on this project remaining, that the Transit is effectively managing the project and it remains on schedule. The project is on budget. On the Culver CBT test line, project is on schedule and on budget. We have no additional comments there, nor do we have any additional comments on these new interlocking projects as they're such early stage. Thank you.
Thank you. Finally, capital program commitments and completions, our COO, Nuria Fernandez.
Thank you very much, Mr. Chairman. I didn't think I had slides, but I do. No slides. Please get the lights. Thank you. If you will refer to section 4 in your books. As you all may recall, our goal for our capital program is to have in fiscal year 2013 to award design and construction contracts in the aggregate amount of $5.49 billion. Our commitments through March, that is for the 1st quarter of this year, were forecasted at $1 billion. Today I'm reporting on the status of 10 major projects, commitments through the end of March. Of these, 8 were awarded on time and within budget, and 2 other major projects have been delayed through June. This 1st quarter, the operating agencies committed $1.1 billion, which is $100 million over what we had anticipated. And this happened partly as a result of Long Island Railroad awarding a large part of its 2013 track program ahead of schedule. Also, the brick arch ceiling repair contract at 168th and 181st Streets stations were $16 million higher than what was budgeted. So I want to draw your attention to that on page 4-2, the frame that refers to budget analyses. It shows the difference between our year-to-date versus year-to-date actual versus budget. And the reason I wanted to point this out is that I do believe, based on the trends that we're seeing, that the days of favorable bids may be coming to an end. The $16 million over budget was over the estimate that we had established, and that was the lowest bid. Now, I would like to move on to completions, that is, projects that were completed this first quarter. Again, just in terms of reference, for fiscal year 2013, we have forecasted $5.45 billion worth of contract completions. Our goal for this first quarter was $469 million, and today I'll be reporting on the status of 7 major projects that were scheduled to be completed in this first quarter. 6 projects were delivered on time and close to budget. 1 project has been delayed through June of 2013. That is the MTA Fulton Center air-conditioned mezzanine, which is $175 million. Through March, agencies have completed nearly $99 million, that is 21% of the year-to-date goal. That completes the report on the capital program status, Mr. Chairman.
Thank you. And if there is nothing else, I'll entertain, there isn't.
Noria,
Yes.
on page 4-6, where you've got this thing in red, you have to remove the M from that mezzanine. It's no longer there.
Okay, very
It's
well.
JZ.
It's JC. We will remove the M that no longer comes. Thank you very much.
Similarly gone is FML. Anything else? Motion to adjourn? Second, all in favor, the meeting's adjourned.